For this, y'all are going to use your calculator and insert in, to find the linear regression, y'all are going to insert in the X in your A list, and your B list is going to be the Y's, into the spreadsheet tool in your calculator. And then we're going to perform the regression. Watch the video of me doing that. Okay, so we're going to be working on trying to get this information from the warm-up into your calculator. And so you'll go into, on your home, you'll go to the spreadsheet, and you'll type in your data points. I've already got mine typed in, and they should go in your list A and B. So we're going to find the regression, and to do that, you're going to go into, type in your A and your B, which is your X and Y's. And this is in that spreadsheet feature in the home screen of your calculator, which is in the very center at the bottom. To do the calculations, you go to menu, down to statistics, which is 4. You're going to go to stat calculations, and you're going to go to number 3, linear regression with MX plus B. The 3 and 4 will actually work, but 3 is going to be more in the format that you're used to it. For the X list, you're going to do A in the square brackets, and for the Y list, you're going to do B in the same square brackets. And then you're going to find the linear regression. It should show up in columns C and D. C is going to tell you all the titles of everything, and D is going to give you the information. And up here at the top, it's going to tell you the formula. It's going to tell you your slope is 1.2. Your B is 31.3 continuous. Your R square is 0.9. And those are the pieces of information we need to have. And I'll talk about that when I go to the other program, and we'll write that information in on our screen. You should have found that your M was 1.2, your B was 31.33 continuous, and your R squared was 0.9. So what that means is the equation is y equals 1.2x plus 31.3 continuous. And this has a 90% accuracy based upon your R squared. That means this is a pretty good regression. It's not the best, but it is a good start. So we are going to be looking at how data lines up, and we're going to be looking at creating that model. So let's look at a 12-ounce can of soda that's been put in the freezer. So we're going to describe this distribution as the temperature decreases. Volume first decreases and then starts increasing. And we're going to find the regression of this, or first off, y'all are going to plot the data points. So go ahead and plot the data points on this chart. You should have had your distribution looking like this. And remember, this is 55, this is 55.5, 56. A lot of people that had troubles with this were trying to make these a bigger jump than what they really are. This is only a point. Here is where most of your information is going to fall.
I need all high school girls that.
And so now we're going to take this information, and y'all are going to put this information into that spreadsheet utility we used for the linear regression, and we're going to do a quadratic regression because this is a parabola that's being formed up. So in this this problem, we are typing in our temperature in X into the A and your volume into your B, or your Y value. And you should have 8 rows of data. Now we need to calculate it. So before we were looking at, in statistics, we were looking at a linear regression because we were looking at a line. But when we saw the graph and we did our scatter plot, it wasn't a line it formed. It formed a parabola. So we're going to go to quadratic regression. Same idea is going to apply. We're going to do A, and then control, and then that square bracket. And then we're going to do B, and the square brackets. And then we're going to graph it, or not graph it, but find the points. And so, because this is quadratic regression, it's going to go into the standard form. So we have our A, B, C, and our R squared. But on my A, you notice how it has e to the negative 4? That's one way it can show up. But let me show you another way it may show up on a calculator. The other way you might see it is like this. And the reason these are the exact same thing is oops, it's like one way. This one has, if you look at it, if you hover over it, you'll see it has an e to the negative 4 at the end. And that tells us that it's times 10 to the negative 4. And I'll show you on the paper here in a minute how that worked. Notice that your R squared was 0.99425. So that means this is a pretty accurate piece of data. And so when we did that, you should have found A is equal to that 0.00088. B is equal to negative 0.07223, and C is equal to 356.35. And your R squared was 0.99 something. So what that means is we have the equation of y equals 0.00088 x to the second minus 700ths, actually more accurately a little bit farther out than that, x plus 356 and 3500ths. So this is my equation of the line that best fits this data. And so if I look at this data, it looks like on the left-hand side it's a pretty accurate fit, but as we go to the right-hand side, it doesn't seem to fit as accurately. And we're going to actually see what this looks like on the graph for yourself. So go ahead and type this in your this equation in your graphing calculator. Then adjust your window to where x max, it goes x min first, is at 0. X max is the 100. Our scale is by 10. Y min is 352.5. Y max is 357.5. And I am counting by my scale for the Y is 5/10. And so when you see that graph, it lets you see kind of how it fits. So we want to compare the domain and range of the function to the problem situation. So in the function, my x's are going to go on forever. So negative infinity to positive infinity is my domain. My range has a low point. And that low point is going to be, oops, I can actually be there. So that's a square bracket. $354.88. And that goes up to positive infinity. For the problem situation, it's going to go from that chart. What is my domain and range? Well, my domain are all the temperature values, so that 14 to 68. My range are all the different values I found for my volume. So 355.54 through, 0.88. Let me try that again. I have written down the wrong one in the wrong spot. 354.88 to 355.54. And when I try to look at this, the next question is asking us, what does that y-intercept mean? So that y-intercept is the volume when the temperature let me get rid of that. When the temperature is 0 degrees. So it has a volume of 356.35 cubic centimeters at 0 degrees. Now, we did not cross the x-axis. So what that means is there is no x-intercepts, which means there is no point in which the volume is 0 in the story. There's no temperature I can set it at that's going to create a volume of 0. Now I want you to try to do the predictions of the different volumes of soda based upon the temperature. So when it's 20 degrees Fahrenheit, you're going to plug that into the equation. Y equals 0.00088, 20 squared minus 0.07223 times 20 plus 356.35. And that will give you your value of what the volume is. You should have come up with a volume of 355.26 centimeters cubed. And then you're going to do the same thing for the 60. At 60 degrees, you should have come up with a volume of 355.2 centimeters cubed. And now for homework, I want you to model the problem situation and describe how this model fits with any limitations of the model